Okay, we're doing long division of polynomials. I know you probably don't even have a clue what that really means, but I hope you remember what long division is. We're going to review it in a minute, but if we're going to do long division of this polynomial, poly means many, polynomial, it's got many terms, and I'm going to divide it, I'm going to take this and divide it by that. And what it'll look like is this: x minus 1 goes into x squared plus 2x minus 3. And that probably should feel incredibly daunting to you right now because you have no clue how to do it. The cool thing is, in a few minutes when I'm done talking to you, this is an easy one. You'd be able to do it. Yeah, no problem. Okay, let me show you how. So first thing we got to talk about is long division. Is 3 a factor of 22? Well, 3 goes into 22, but does it go in there perfectly? Okay, so you'd go like this. Does 3 go into 22? Everybody write this out on your paper, on your virtual paper. Does 3 go into 22? You would say, well, yes, it does go into 22. Just not perfectly. Okay, it goes in there how many times? 7. Because 7 times 3 is, and then you put it down here. You multiply the 7 times the 3, and you make 21. Then, what do you do to those two numbers? Do you remember this? Subtract them. That's right. 22 minus 21 is 1. You need to remember how to do this. This is plain long division with normal numbers. Then we're going to move that to doing it with variables. Okay, so we got to get the basics first. This one's called the divisor. This one's called the dividend. We realistically don't use the answer. Excuse me. You usually don't use those terms very often in here, but it is true. This is the divisor. This is dividend, and it's in the den. See, like the bear climbs into the den to hibernate. It's in the den. See, it's in here. Okay, anyway, the dividend is in the den. All right, now what do I do with that 1? Well, if I'm really factoring, I'm supposed to write this for my answer. 3 times 7 makes not 22. Dang. But what do? I take that leftover 1. Yes, you could drop down a 0 and get a decimal for it, but we don't need to. We can just say our answer is this. 3 times 7 makes 21, but it's really close. But then what do I have to do to make it work? Plus 1. Get out 3 times 7 is 21. Plus 1 makes 22. That's what we're trying to do. We're trying to figure out two numbers that would multiply and equal this. Now, it doesn't happen to work out perfect, so we have to use this leftover right there, the remainder. We have to use that remainder to get my final answer, which was the 3 times the 7 plus the 1. All right. Is 7 a factor of 83? And the answer is always going to be yes. It's just a matter of yes, but you might have a remainder to make it work. I get how the answer is kind of no and kind of yes on this, because 7 doesn't multiply nicely into 83. But we can kind of cheat and do 7 times something plus something. All right, so everybody right now should be setting up this 7 into 83, and the dividend is in the den. The 83 is the dividend. In case you get asked that one on a test, it'd be good to know how to tell those two words apart. The dividend is in the den. All right, 7 goes into 8. Ooh, I don't even have to do it. 7 goes into 83. I can do 7 goes into 8. 7 does go into 8. How many times? Once, so you put a 1 right there. And then underneath it, you go 7 goes into 8 one time. So I put a 7 right here and I subtract, and is there any left? Yes, there is. There's a 1. Do you know what to do with the 3? Bring it down. Now you ask yourself, does 7 go into 13? Yes, but not perfectly, but yes, it does. How many times? Once. And 7 goes into 13 how many times? Once. And then I put 1 times the 7 makes 7. And then 13 minus the 7, what do I have left? A 6. So that 6 is called my remainder. So now, my final answer for this thing is, I would do 7 times 11. That made 77. And then what? Plus the 6. That makes sense to you? All right. I want to get you to one more step just because I think this is kind of a silly way to write it in a way. But we need it that way because we're teaching you the polynomial stuff. And if there's a leftover in the polynomial stuff, usually you do it this way. But I would have said that the answer for this was 11 and 6/7. Do you get how I got that? 11 should be pretty obvious. Where's the 6/7 coming from? 6/7. All right, but that's just me trying to show you what the real answer would be. What is 7 going into 83? It goes in there 11 and 6/7 times. Okay, so another right answer would be 7 times 11 doesn't really actually work, right? But 7 times 11 and 6/7 would work. That would equal 83. All right, you don't have to know that way. I just wanted to show it to you because that's what your elementary school teacher taught you a long time ago. When you learned them really simple, when you learned things like, does 7 go into 8? And you'd say, yes, it goes in there once. And I have 7, and I subtract, and I get a 1. What your teacher probably taught you to do was to say the answer was 1 and, what in this case? 1 and what? 1/7. 1 and 1/7 is the right answer. Let's do one more like that. 8 goes into 33. Dang, if it was just 32, it would have worked perfect, right? 8 times 4 is 32. There's 1 left over, so what's the answer? 4 and 1/8. But instead of 4 and 1/8, what we're going to have you write is how can you factor 33? You can factor in an 8 times 4 is 32, and that's really close, plus 1. You get the difference? All right. I think you're almost ready. Try factoring that using the long division. Go. I'll pause for a second, see if you can handle this by yourself. I know some of you are stuck right here. For those that don't know what to do, 18 does go into 28 once, and then I got 18 right here, and I subtract them, and I get 10 left. What do I try to do? Bring down the 8. And then you got kind of a tough one. Does 18 go into 108? Ugh, pain in the butt. How many times? Anybody figure it out? 6? Does it work out perfect? Awesome. 6 times 18 then. So I'm going to go off to the side and do it this way. Do it any way you want, but that's the way I do it. Because I got to do this times this. Okay, 16 times 8, 6 times 8 is 48. 6 times 1 is 6, plus 4 makes 10, 108. Yes! Final answer is there was no remainder. So what's the point? You're factoring it. So you're supposed to say it's 18 times 16. Raise your hand if you had that one right. A lot of people. Nice. Okay, I think you're ready then to move up to this. This is that very first problem I showed you and said that this one would be one you'd know how to solve by the end of the hour and would say it's an easy one. Let me show you how it works. You go x minus 1 goes into x squared plus 2x minus 3. The dividend is in the den. So the dividend is the x squared plus 2x minus 3. Okay. Well, do you get that I'm probably supposed to write something up here? Any clues what? Take a guess. Just take a guess, and I'll multiply it out and see if it works for you. Yes? Yes, so I'm going to have to, I'll end up with something like x plus 7 here or something. Yes, but we do that one step at a time. So what you ask yourself is, what could I put right here so that if I go this times this, it would equal that? All right. Let me show you why we're doing that. I'm going to, off to the side, I'm going to show you a parallel problem. That's where you put two problems side by side and you say, how is this one like that one? Let's say I was going 3 into 71. Do you get my first step would be to figure out something that goes right here? And I would say, 3 go into 7? And I'd say, yeah, it goes in there a few times. 3 times 2 makes 6, and then I would subtract them. And well, how can I do that over here? You got to put something right here so that this times this will go right in there. Come on, somebody can do this. What should the question mark be? Yes, sir. All right, hold on. We're going to start with the x. You don't want to try to do it as complicated as what you just did because most people will not be able to do that. But we can do with the x. When I multiply the x, times the x, do you get how it makes x squared? All you have to do is make it match up with that first term. I had to figure out something to put here so that that times that would equal that. Okay, now, does it have to also multiply by the minus 1? Yes, it does. X times the minus 1 makes negative x. Then we always drew a line here, right? And then what do we always do next? We subtracted. But, think about this. If I just go like this and put a minus on just the first one, do you get how that's kind of wrong? Whenever you have two terms like that, you just can't make just one of them negative. That doesn't make sense. You have to put a negative on both of them like this. And so I don't like to use those parentheses. Some teachers do. But I personally would rather just say, this is negative, but I also have to change this to positive. Basically, that negative has to get distributed. Both of those things need to change signs. Now, the cool part is this cancels this. And 2x plus x makes 3x. Then I bring down the minus 3. That's also just like over here. When I do this and I get 0 left, I bring down the 1. Oh, wait, I would have 1 left, sorry. And then I would ask myself, does 3 go into 11? And if it does, I put something right here. 3 times what makes 11? And I would go, oh, 3 times 3 makes 9, and that's pretty close. So I go 3 times 3 makes 9. It doesn't have to work perfect. It can be a remainder. And there'd be a remainder of 2. Okay, so over here. What do I put right here? And I think you had it before. What did you say it was? Plus 3. And my plus 3, I go 3 times the x makes 3x. 3 times the negative 1 makes negative 3. Notice I want to match it perfectly, and I did. Don't forget this step, though. A lot of people forget this step. Change this to the opposite of itself. It was a plus. Now it has to be a minus. And change this to the opposite. If it was a minus, now it's got to be a plus. That way, this will actually cancel this, and I'll actually have 0 left at the end. So what just happened? Final answer. That times that. X minus 1. X plus 3. Now, somebody's smart. Is there some other way I could have figured this out? What could I have done? Just could have factored that thing underneath. If I had just factored this, it would have worked. But here's the thing. We're showing you this method because we're going to ask you to do ones like this. And this one wouldn't factor by grouping. So you'd have to do something like this. And is there any way you're going to factor that thing in your head without factoring by grouping, which you can't in this one because it wouldn't work? No, there's no way you're going to factor that sucker in your head. But you can long division factor it. I'm not going to ask you to do it right now because you're not ready yet. But the point is, you need to know this method because it'll work for any polynomial, not just the easy ones we've been working on. All right, so let's do one more. Everybody go to number 6. X minus 3, x squared minus 7x plus 12. I'm going to walk you through this one more time. Mr. Green Shirt, tell me how to start. Not using your name because we're recording. I need to put something here. Do you have any clue what? That's an excellent guess, but no. I want this to match this perfectly. I don't want it to be the opposite. So you tried to think it extra smart and you went too far. Just x. Because I want that and that x times the x to make a normal x squared. I want them to match up perfectly so that when I change its sign later, then they will cancel each other out. Okay, so plain old x up there. And I'd tell you most of the time, it's just going to be x. You're going to have first on the easier problems. On the more complicated problems, it might be like 2x needs to go up here. But anyway, okay. X times x makes x squared. X times negative 3 makes negative 3x. Draw the line, and here's where a lot of people screw up. They just jump right into the problem and cancel these out and stuff, and you can't do that. Don't forget to change both signs first. This changes to negative, this changes to positive. Now I can make these cancel. Now I can put these together and I won't screw it up. that's not 10, it's going to be negative 4x. Then I bring down the 12. And I know some of you are thinking, I can just factor this, I can just factor this. That's going to burn you in just a minute when you have the 4-term or the 5-term ones. So for now, that's true. It would work to just factor the thing on the inside. And you could say, oh, it must be, let me think, 3 times, it's probably a 4. But trust me, you want to learn how to do this for the hard ones. Because I'm not worried about you on the easy problems on the test. Almost everybody gets the easy problems right. It's the hard ones that are coming. So learn this method. Next step, I got to ask myself, what can I put here so that this times this will make the first term match up? If the second term matches up, that's just a bonus. But like here, they didn't match up. But if they don't match up, that's all right. The first term has to match up. So do you get that this has to be a 4 and therefore a positive 4? Raise your hand if you already had a plus 4 on yours. Okay, some of you are ahead of me, and that's a good step. Good sign. Okay, 4 times the x, 4x. Oh, wait a minute. Wait a minute. That didn't match up perfectly. Should have been a minus 4. Because now the minus 4 times the x makes minus 4x. Now they match up perfectly. Then when I change their signs later, they'll cancel out. See? All right, so I wanted it to match up perfectly. Now the negative 4 times the negative 3 makes positive 12. And now I change my signs. Don't forget that. Plus and a minus. Notice that makes this and this opposites of each other, so they cancel. This and this are opposites of this, so they cancel. I have nothing left. I have figured it out. It's x minus 3 times x minus 4. Does that make sense? All right. It gets a little more complicated, believe it or not. This is saying that part I was telling you before. Obviously, we can factor trinomials. We could have just factored it in the first place instead of having to use long division. But we're going to be doing ones that have 5, 6, or even 7 terms on them, and you won't be able to factor them by hand, but you'll be able to factor them with this method. Okay. You know, I think we've done enough easy ones. I'm going to skip through a few of these examples. This one's a little different. Look at how this one looks. See, it says x plus 2. And you'd go, you know, x plus 2, and then you'd go 3x squared plus 13x plus 14. What happens when it looks like this? X equals 2. Is that a solution? If x equals 2 was a solution, do you get that that means that the little parenthesis it was in would have had to say x minus 2? If x equals 2 is the solution? You know what I'm saying? If I can put, if x equals 2 is the answer, then that means I put in this and it makes it equal 0, right? So when they ask you, is x equals 2, you put x minus 2. All right, so x minus 2, and then the other part is this, 2x to the 4th minus 3x to the 3rd minus 5x squared plus 3x plus 6. You're in an honors class. This is the kind of question honors students have to be able to handle. That is not insanely difficult, but I'd say it's in the top 3 on the test that you would have on this. One of the 3 hardest questions. See if you can handle it right now. Give it a shot. Do the long division. You're stuck on the first step. You're trying to find a number that goes right there so that whatever this is times this will equal that. I'm going to pause for a second while you work on that. Okay, many of you figured it out already. Nice job. This one has to be a 2x cubed. Notice I didn't put anything over this. Why? Because x minus 2 doesn't go into this by itself. So you technically need to have this answer moved over here one notch over. That's where I've started all my answers. Okay, now why did I pick 2x cubed? Because 2x cubed times x will make 2x to the fourth, and it matches up with the one above it perfectly. Now, whatever the next one comes out to is okay. It doesn't have to match. Sometimes it does, sometimes it doesn't. So that's going to be 2 times negative 2 makes negative 4x cubed. Next step, you got to do the opposite thing. This becomes 9 minus, this becomes plus. Now these guys can cancel. Yay. These two get subtracted down, and it's negative 3 and positive 4 makes 1x cubed, or you can just say x cubed. And I got to bring this down. Minus 5x squared. All right. Now I'm going to have to go, what goes here? Plus x squared. Raise your hand if you got an x squared right there. Awesome. Then you're on the right track. X squared times the x makes x cubed. X squared times the minus 2 makes negative 2x squared. Notice I get to do my sign change thing. Minus here and plus there. A lot of people forget that. Because if you got a 7 right there, that was wrong. It's negative 3x squared. Now I got to bring down this 3x. Plus 3x. Holy cow, this is a long problem. And then I ask myself, how can I make a negative 3x squared? What can I put here so that I will get a negative 3x squared? And it means to be a negative 3x. Did anybody get that far? Sweet. Got my 4 or 5 people that are able to handle this right now, and the rest of you, you'll get it. You just maybe you're not there quite yet. So negative 3x times the x makes negative 3x squared. And the negative 3x times the negative 2 makes positive 6x. And then, it's so easy to forget this, change both signs. It's a negative 6x now. And then I have those canceling. Negative 6x makes negative 3x. And then I got to bring something all the way down here. The 6 comes all the way down here. Plus 6. And then I ask myself, what should I put at the very end so that I can get a negative 3x? It should be a negative 3. And the negative 3 times the x makes negative 3x. And the negative 3 times the negative 2 makes positive 6. Change the signs, plus and a minus. And this cancels out and cancels out. Sweet, I have 0. It worked. Final answer. That times that. X minus 2 times 2x to the third plus x squared minus 3x minus 3. Whew. I'm really glad I came back for today, because that's hard stuff, and I know you could have gotten it, but I'm glad I was here to be with you through it, because this stuff is hard. It's not impossible, but all right. Let's start one last kind of problem together so you can see what happens when there's something called missing terms. And then we'll do the first problem on the homework together. All right, so missing terms. Take a look at this problem and try to figure out what's different about it than all the other ones before it. It's missing an x. It's got an x cubed, it's got an x squared, but it doesn't have a plain old x in it. So if you don't notice that, you'll just go through the whole problem happily doing it and get the total wrong answer. Okay, because you won't even, if you don't even notice it, you'll never notice, and you'll get it marked wrong later, and you'll be like, oh crap, I forgot the missing term. The thing you have to do if there's a missing term is you have to put in a 0 to hold the place. Let me show you what I mean. If I had to do 42 times 31, do you remember how to do this? 1 times 2 is 2, 1 times 4 is 4, or 0 to hold the place. And then you go 3 times 2 is 6, 4 times 2 is 12. That 0 to hold the place, we have to do something just like that. We have to have 0x to hold the place. See how there's no x here, but I could go like this, plus 0x plus 15. Now, why will that matter? Because remember how I said things had to line up perfectly? If you don't throw that 0x in there, something is going to get subtracted from something else and it won't line up and it'll get all messed up. You'll be in the middle of the problem going, why is this not working? And I hope that's a reminder to you, so when you take your test someday in the future, it's a ways from now. But when you take the test on this stuff, if you're in the middle of one of these and it's not working, probably has a missing term and you didn't notice. All right, so here's how you do it then. 2x minus 5, it's the same exact thing now. I just have to put in the 0x in the right spot. So 2x cubed minus 9x squared plus 0x, that's my placeholder, plus 15. Now it'll work just like all the other ones. And how do I start? Just make sure, I want to make sure you can at least tell me what to start with. Don't say it. Figure out what goes right there, and I want you to billboard it to me, and I'll tell you if you're starting right. Go ahead. Write down the problem, and then show me in that spot what should go right there. All right, I'm getting different answers from smart kids. Think carefully. All right, I'll start telling you if you're right or not. Okay, turn it around as soon as I say you're right. Yup, yup, yup. Keep it to yourself so other people can't see it. Yup. Nope. Yup, yup. Yes, except your x squared needs to move over one notch. Yes, 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 yes. Everybody's pretty much, well, I'm not sure about that last one. Pretty much everybody's saying x squared and you're right. Now somebody I think had a 2 on there and I didn't notice that before, but somebody that had a 2 here, I hope you get that that would make 2 times 2 makes 4x squared, so there should not be a 2 right there, sorry. All right, x squared times the 2x makes 2x to the third. That's how you'd start. And x squared times the negative 5 would make negative 5x squared. And then these guys cancel because these change to opposites. Those cancel, and then I got to subtract those two, negative 4x squared, and then I just keep going from there. Bring down the 0x just like it was a normal term. All right. Okay, I think that's enough practice. The hard ones have the missing terms, and all you have to do is throw in a 0 for it. No biggie. All right, now let's find the homework. Everybody go to your Schoology page, and you're looking for the homework that was assigned on 2/26. The homework assigned on 2/26. I'm going to pause till I get that up. Okay, your worksheet looks like this. It says 7.6 to 7.8 higher degree factoring on it. Get there quick because I'm going to be doing the first couple of problems with you. Underneath the title it says long division. Right up in here it says long division. I know you can't see that on the video at home, but all right. So use long division, and the very first one they throw you has a missing term. 9x squared, and then what should come next to hold the place? Plus 0x minus 4. Now remember, you're trying to make the first term match up. We need something that goes right there so that that times 3x would equal 9x squared. Some of you guys are really good at this, I know, so help me. What is it? 3x. If I put a 3x here, 3x times the 3x makes 9x squared. Yay. And then the 3x times the plus 2 makes plus 6x. Then I change the signs of both of them, minus and a minus. I bet some of you forgot that. So easy to forget that. Then these guys cancel, and this becomes negative 6x. Bring down the minus 4. Now I got to figure out what do I put here so that that times 3x will make negative 6x. I hope you knew it was a minus 2, right? Negative 6x minus 4, change the signs, plus and a plus, and now they cancel all off, and I get 0 at the end. Yay! I've got my answer. The factored form is right here. 3x plus 2, 3x minus 2. 3x plus 2 and 3x minus 2. I'm going to try to squeeze it in real small here. Okay, now the real solutions, that just means set it equal to 0 and figure out what does this have to be. I can do those in my head by now. Can you? That has to be negative a fraction. Can you do it? Is it 2/3 or 3/2? negative, let me make sure you're right. 2/3, 3 times 2, yes, negative 2/3, good. And what little fraction would go in here? Positive, what? 2/3. Those are the real solutions, and were there any imaginary solutions? The only way you'll know is by doing it, and if one of your solutions comes out with a square root of a negative in it, then that's imaginary. This doesn't have any square roots of negatives, so there are no imaginary roots. Just write none, because both your answers are normal numbers. Again, if your answer had come out to a square root of a negative, that'll happen if you ever have like something like this in a parenthesis, like that. Because then when you solve that little thing, let's say you had one like this. This answer would be -4. That's an easy answer, and it's a real answer. This one, you'd have to go x squared plus 9 has to equal 0. X squared has to equal -9. Square root of x squared is absolute value of x. Has to equal the square root of -9. As soon as you have that, you've got imaginary solutions. If you ever end up having to find a square root of a negative, that's when you'll have imaginaries. Okay, so this assignment's a little too long. So I'm going to ask you to cut out a couple just to make it more realistic of what you could get done by tomorrow. You may skip problems 4 and 6 off of today's. That cuts off 2 of the nastier ones. Okay, so 1, 2, 3, and 5. Skip problems 4 and 6. I try to be realistic, but on the other hand, I expect you to have your homework done. I know you probably didn't grade any with Mr. W while I was gone, right? Okay, I am promising that this one will get graded and put in the grade book tomorrow. Okay, so I need to get you back in the habit of getting homework done and graded. I'm sure most of you were smart about doing your homework while I was gone, but I don't know. But I'll know tomorrow whether you did this one. Okay? All right, that's all I got for you for today.